Hello, everyone, and happy Sunday to you. I don't know about you, but I know there's a lot of people feeling a little lost because football season's over. But guess what? Baseball season's right around the corner, and then we still have our basketball season. So don't feel lost. It's still here. Hello, Milton. So, welcome. I guess I'm going to call this tutoring with Audrey. Why not? So what we do is we normally just come here, do some math problems, kind of build up your skill set a little bit. Before, like some of you guys are taking some college courses. Let me turn this down a little bit. I feel like I'm shouting. But I had some cancellations today and I was like, you know what? I'm pumped to do some math, and guess what? I'm going to do some math. So hello everyone and welcome in. So what we're going to do today, because since this is a little off script, really want to hit hard on those basic concepts. So I really want to hit hard on fractions, doing some decimal work, and then also figuring out ways to solve those pesky word problems. Like, what is it that we need to break all these concepts down? So, without further ado, if you have everything ready for you, I'm so glad that you guys are coming in. And then if anything, if you can't really stay, you know there's always going to be a replay. All right, so we are going to be looking at adding and subtracting those fractions. Now, the key thing when you're dealing with fractions, and this is what kind of opened me up, is that fractions is just another way of doing division. So the way that fractions are set up, if you ever look at the fraction or the division sign usually has, okay, there's a fraction bar, and then there's two dots. And everybody's like, oh, okay, fraction bar with two dots. That's great. But do you know what those two dots mean? Okay, do you have any idea what those two dots mean? These two dots mean numbers. So when I look at, say, something like 18 over 24, these two dots are representing numbers that's going to be placed in what's called the numerator and the denominator. All right, paper and pencil ready. Good job, Tracy. All right, so of course I'm feeling a little rebellious. I'm using a pen, but sometimes the pen kind of shows up a little bit nicer. So let me see if I can zoom in just a hair so you guys can see a little bit. All right, so when you look at a division sign, it's also known as a ratio. So a ratio is something out of something. So when you're doing a division sign, this is representing a number and this is representing a number. So when we take a look at 18/24, I know if I try to divide that, I'm going to get a decimal. So instead of dividing, we want to do what's called simplifying. And this is something that is needed to know before we get into our adding and subtracting of fractions. So simplifying, we need to figure out what is our, as they like to call it, the LCM. Okay, what is the least common multiple that's going to work for all 18 and 24? So this is where your multiplication table is really going to jump off, right? So then I know some people, it's like, I don't know it off the top of my head because we're so used to dealing with this lovely thing called a calculator. And that's perfectly fine. But then I designed something that kind of helped us out a little bit. So this is a factor sheet. And we're looking at factors of 18, which is right here, and 24, which is right here. So if you look at the 18 and the 24, we want to know what number other than 1 do they have in common. All right, so there's a 24, 18 doesn't have the 24. They both have a 2 in common. Okay, that works. They don't have a 12 in common. They don't have a 9 in common. There's a 3 in common. All right, there is a 6. And it seems like the highest number that they both have in common is a 6. So that's going to be your least common multiple. Hey, Ray, how are you? So nice to see you again. All right, so my least common multiple is going to be 6. Yes, both of the numbers are even, and yes, you can use 2. All right, but let me kind of put that in pencil over here. If I used 2, so if I have 18 over 24, and when I reduce, you're basically dividing both the numerator and the denominator by 2. When you do that, you got 18 divided by 2, that gives you 9. And 24 divided by 2, that gives you 12. So now I'm looking again, 9 and 12, they both have something in common. They both have a 3 in common. So if I divide that numerator by 3 and divide by that denominator by 3, 9 divided by 3 will give me 3, and 12 divided by 3 will give me 4. So 18/24 can be reduced down to 3/4. And there's nothing wrong with that. That's perfectly fine. But if, instead of going by 2 and then again by 3, if I can come up with the largest number, which is 6, if I divide my numerator by 6 and divide my denominator by 6, 18 divided by 6 gives me 3, and 24 divided by 6 gives me 4. So notice you get the same answer. One just took a little bit longer than the other, but guess what? You're going to get the same exact answer, right? Yes, Miss Gemini, hello. I'm just looking up. I'm sorry, guys. Aw, I would love to be your teacher. And this is the best thing about being on here. I can be almost anybody's teacher, right? And that's one of the reasons why I personally left the classroom, because I didn't want to just be a teacher at one particular school having the same type of students. Now that I have my own online tutoring, I have students throughout the US as well as some parts of overseas. All right. So this is how you reduce. You're always looking to see, oh, I just found you. How are you? You're always looking to see what is the largest number. And if you notice, 2 and 3, 2 times 3 also gives you 6. Look at these numbers just flowing out there. Oh, please, Bree. I hope so. I hope it changes. I really do. It's kind of tough when you're in the classroom and there's a lot of students in there, and then especially with the amount of curriculum that they have to cover. So it's never really easy. But this is what you do to reduce your fractions. And don't forget, fractions is just another way of doing division, all right? So if I may, let me see if we can reduce this again. So we have, let's say, 35 21st. Okay? 35 21st, that is called an improper fraction. The reason why this is called an improper fraction is because my numerator is bigger than my denominator. All right? So it's improper. It's not posh. It's not demure. Okay? Because my numerator is bigger than my denominator. But we can reduce this before we tackle on. Okay? Instead of LCM, isn't it the GCF? The GCF is going to be the greatest common. So sometimes GCF will be if I multiplied. Okay, so sometimes like for 24 and 18, it's going to be my largest number. So if I multiplied 18 and 24, and I'm not going to lie to you, I'm putting it in the calculator right now because I'm not a throw-on genius. If I wanted to say the GCF is going to be 432. Yeah, way too big. We're trying to simplify it. We're not trying to factor it. We're trying to simplify. So when we're simplifying fractions, we're using the LCM. If we're trying to, I know my my phone's doing something funky. If we're trying to do the factoring, so we can take it to its original spot, which we are, let me see, I think we are doing factoring. Yep, I'm doing factoring starting this week in my PM sessions at 8:30. So if you guys want to come back for that, you can. Now, 35 and 21. So we want to know, what number do they have in common, the least common multiple? So we have our 35. Okay, cool. They're on the same side. So we have my 21 and we have my 35. I think I can put everything on the same screen. All right. So other than 1, what do we have in common? All right. Obviously 21 and 35 is not going to work. Then we have 3 and 5. That's not going to work. Yes, Tracy. Tracy's on top. She was all ready. Okay. So 7 is going to be what they have in common. So I'm actually going to, got a little crazy. I'm going to actually divide the numerator and the denominator by that 7. So what happens? 35 divided by 7 gives me 5. And 21 divided by 7 gives me 3. So 35 21st and 5/3 are equivalent. Okay, they're equivalent because if I multiply 5/3 by 7, I will get 35 21st. And 35 21st divided by 7 will give me my 5/3. Okay, how are we doing? I'm loving the hearts. Thank you so much. Okay, did I lose anybody in the sauce? Okay, I like to always say, because sometimes I like steak, sometimes I don't. But I always like to say, if you want food to taste really good, you got to let it marinate, right? You got to just keep it in there for a little bit. Oh, thank you, Susan. Okay, Ray. Yep. Got to let it marinate. Let it process in your brain a little bit more. All right. So, I understand this so well. Good. All right, Isabella. Good job. All right, so let us do one more. And what I'm going to do is I'm going to let you reduce it. All right, and then we're going to check each other's answers. So I have 2472. And yes, you can use a calculator if you need to. 24 70 seconds. 24 70 seconds. What would that be reduced? Okay, I'm going to give you some time. Okay, I got something from NC. Got something from Bree. If you multiply, you got 1/3. We got Ray with 1/3. Okay, it seems like a common theme. For those that haven't written down, don't stress. Tracy, we got 1/3. Let me see if I can hear from, yes, Isabella. I was going to say, let me hear from one more person. Okay. So, if you put in your calculator, or if you just know, all right, if I got 24 hours and 72 hours, 24 hours is 1 day, 72 hours is 3 days. That means I can divide what they have, the least common multiple would be 24. Everyone's like, oh, I didn't think of it that way. And that's all right, because 24 divided by 24 gives me 1. And 72 divided by 24 gives me 3. Now, since both of them were even, and if you try to divide it by 2, that's fine. That means you divide it by 2, then you divide it by 2 again, then you divide it by 6. Okay, I actually did it in my head. Look at you, Temper. Temper, good job. Okay, on the last one, why wouldn't we make that an improper fraction? Didn't think you can keep the answer. Now, here's the thing, Tracy, because it all depends on the teacher and it also depends on the question. So right now, I'm just working on just simplifying. So I know most people will be like, we don't want you to leave your answer as an improper fraction. Some people might want you to change it into a mixed number. Okay, so if we need to change this, here's another thing. If we ever need to change an improper fraction to a mixed number, yes, we're actually going to divide it. So remember this old time division? So my divisor is going to be the 3. The dividend is going to be the 5. How many groups of 3s can go into 5? One group of 3. 1 times 3 gives me 3. Then we subtract. 5 minus 3 gives me 2. So this 2 is going to be my remainder. And we always put the remainder over the divisor. So that means we have 1 and 2/3. Okay? So sometimes, especially later on when we talk about slope, you can leave it as a fraction. That's why sometimes I don't really change it, because when you deal with slope, you don't have to change the fraction. But I never got this right in school. Oh, so how are you feeling, Teresa? You feeling okay? Okay, yes, mixed numbers. That's what I meant. Not a problem, Tracy. Yes. So if you're dealing with, like, say we had to simplify it so we can figure out, say, the slope or the rate of change, which we're going to actually talk about, I think this week. I know I have to keep looking at myself. Yes, this week. That's going to be the 1 o'clock. You can leave it as an improper fraction. But if we're taking, say, the GED, the ASVAT, the Accuplacer, any of those assessments, and they say simplify to the lowest term, we definitely want to have it as a mixed number. All right. All right. Thank you so much for the follows. All right. Hello, Lori. All right. So, are we feeling okay with the simplification? Thumbs up if we're good. I'm still on GCF and LCM. I'm pretty sure you use the greatest common factor to simplify. Okay, thanks. Do you do study courses for SAT, ACT? Yes. WMAP? I've never heard of that one. WMAP? I've heard of MAP, not WMAP. That was interesting. Okay. Need more simplifying. Okay. Okay. Hey, Robert. Robert's my bestie. Go and follow him. All right. So let's do one more. Let's see if we can do this. So if I... Hey. If I can... Just want to make sure I'm not skipping over anything. Let's say 16. Let's do another example. So let's do 16 over, what can I do? 16 over 56. Why not? So what's 16 over 56? Can I get an online classes with you? Of course. Can you do a lesson? No, not today. Annotates. Yeah, today was just really, I just threw some stuff together, to be honest with you. Yes. Oh, Robert. Yes, I did get your postcard. Thank you. Of course, you can't see it. But my friend Robert gave me this postcard. It's gorgeous. Love it. Out in Utah. Love it. Okay. I don't mean today, but eventually. Possibly eventually. Yes. Yes. I live in Maryland. Do you offer in-person tutoring? I do not. I only do online because I have students, like I go back to back normally for my tutoring. So 1 minute or 1 hour I'll be in Florida, the next hour I'll be in California, the next hour I'll be in Massachusetts, then Maryland, Virginia, Ohio, back to PA, and that is on Monday. So, and not even mentioning on Monday, Tuesday, Wednesdays, and Thursdays, I'm in Alaska early in the morning. So it's like, yeah, I can't do in person anymore. I'm sorry. All right. So I had one person, Ray, said 2/7. Can we just divide and change the fraction to a decimal? You can divide and change it to a decimal, but then you need to convert it back to a fraction. Because when they say simplify, you need to know how to change it back to that. How much is your online class? I'm actually going to tell you something I'm thinking about doing something for just my TikTok people. So I'm actually going to, not a sale, but something that's going to be beneficial for you guys. So each other day of the week, you have different online students. Yes. I have right now on my roster for per week, I have 27 students. And of the 27, 3 of them I see twice. Everybody else I see once. Nope, not Monday through Friday. Sunday through Saturday, I work 7 days a week. Yeah, I'm one of those crazy people that's constantly on. So, 16 and 56. What do they have in common? I need to brush up on that. What's math 342? Okay. So we're saying 8. Tracy says 8. Since they're both even, yes, you can still do 2. But the least common multiple is going to be 8. So if I did the greatest common, that will be my 56. So now 16 divided by 8, that'll give me 2. And 56 divided by 8, that'll give me my 7. And I know how we feel about the 7 times tables. I'm trying, but I had too many cancellations today. And I was like, you know what? I was really in the mood to do some math. And that's what provoked me to come on the live. Just so I really wanted to see if I can help people. And look, I'm helping people. All right. Concepts of business, almost like calculus meets banking and accounting with algebra in it. Ugh, that sounds fun. Yeah, I don't know. Calculus is not my jam. Like, I'll do it, but it's really not my jam. Maybe one day, if anything, you could direct message me and we could figure out a way for you to send me a picture of what you do. Do I teach trigonometry? Yes, I currently have a couple students in trig. Okay, all right. So, how do we do with the simplification? Everybody's like, do you do this? Do you do that? Do you do that? And I'm like, yes, maybe, yes. So, all we're doing is simplifying. We want to find the least common multiple that both has 16 and 56 in association, so we can divide both the numerator and denominator by it in order to get down to its lowest terms. Okay. So, we already did our simplifying. Now, what is the rule? So let's see if we can dig back in the archives a little bit. When you're adding and subtracting fractions, what was the most important thing you had to have before you can do anything? Put it in the chat if you can remember. Yes, calculus is definitely higher than trig. So we need to have that least common common denominator. Yes, I missed the question. So what was the most important thing when you're adding and subtracting fractions that you have to have before you can do anything. Wouldn't it be a common denominator? Okay. So we have a common denominator, least common denominator, common denominator. So if I may do it like an example, let's say I'm going to put it over here. So I have 3/12 plus 4/12. So tell me, is my answer 7/24? Is that my final answer? Sorry, I have to slide that over. So 3/12 plus 4/12. Is my answer 7/24? Okay. Goes Algebra 1, Geometry, Algebra 2, Pre-Calculus, AP Calculus, AB, BC. Yeah, now they have an AP Pre-Calculus, believe it or not, Ray. I don't know. Life is crazy. No. Yes. No, it's not. Thank you. So we're saying 1/3. Why is it not 7/24? Because there's a lot of students that will put that down. If it's not supposed to be that, why is it not supposed to be 7/24? I try. Say that. Everyone look at Tracy's. You do not add the denominators. I wish it was that easy. Yes, it is. You do not add the denominators. Once you have a common denominator, which is my 12, the only thing that you're adding is the numerators. So 3 plus 4, that will give me my 7. Okay, so it's actually going to be 7/12. So now, is there a number other than 1 that 7 and 12 have in common? Okay, why are we multiplying the denominator? Native ash. Okay, they may be added instead of just thinking that the denominator is still going to be 12. Okay. 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 Thank you, Robert. Love you, babes. Thanks. The denominator is like how much of the slices of pizza. The numerator is how many slices of that size. Yes. So it's almost like you want to think of this is the part and this is the whole. So the whole thing, you have 12 slices. But you want to do something with 7, right? So it's always the part over the whole. Okay, makes sense? Yes. So if you know you have, say, in one box of pizza, you have 3 slices out of 12. In another box of pizza, you have 4 slices out of 12. So how many slices out of the 12 of the boxes are left? 7 slices out of 12. Does that make sense? So when the denominator is the same, it stays the same. Yes. Yes. What you're thinking of, native ash, is when you're multiplying. Okay, when you're multiplying and dividing, different rules. But when you're adding and subtracting, you're going to keep it as the common denominator. Okay. Yes. All right. So let me slide over here. So we have 1/3 plus 1/4. Okay, 1/3 plus 1/4. Probably later on, right? But not today. Yeah, I'm doing like as simple can be. Okay. All right. So 1/3 plus 1/4. What's wrong or what's different with this one? Okay. Okay, different denominators. Thank you, Caitlin. The denominators. Thank you. All right, so we need to find a common denominator. All right, so we got to think in the multiples of 3s and multiples of 4s. What do they have in common? Okay, they're not the same. Good. ORG, yes, ORG is saying what we have in common is 12. Sometimes, and I forgot who it was that said the multiplying of 12, when you have unlike denominators, sometimes you can just multiply these two. Okay, sometimes people will say, oh, it's 24. 24 can work, but why go that far when 12 is so much nearer? Okay, so now we got to change this 3 to a 12. Through multiplication, what do I need to do in order to change that 3 to a 12? So we can multiply this side by 4, and whatever I do in the denominator, I also do in the numerator. And this side, we can multiply by 3. Whatever I do in the denominator, I also do in the numerator. So the reason why I'm doing this step here is so people can see where the 12 is. I know I have a feeling that I have some people that are like, yeah, why don't you just multiply over here by 3, over here by 4? You don't have to do it as a fraction. But there are some people that probably don't know why that's happening. So with my sessions, I like to really focus on the why. Okay, so you need to times 4. I don't know. I didn't know. I forgot. Okay, multiply 4. Yes. So what happens is 4 times 3, that's where this 12 came from. Whatever I do in the denominator, I do in the numerator. So now I got 4 times 1. This gives me 4. Same thing happening on the other side. 4 times 3, that's where the 12. Now 1 times 3, that gives me 3. So now 4 12s plus 3 12s should look familiar because we just did it. So my answer would be yes, Lucas. Thank you. Caitlin, thank you. Ray from earlier, thank you. Holly, thank you. Let me double check. And there might have been someone before Ray that said it as well. Okay, just got those guys. Okay, 1/3 of a pizza is 4/12 of a pizza. 1/4 of a pizza is 3/12 of a pizza. Total of 7/12. Thank you, Anthony. Nice job, guys. Okay. So sometimes the visual aid, instead of having what's called naked math, sometimes visualization kind of helps it a little bit. Try to make real world associations with math. You know, there's no separation. Okay. So what happens if I have, let me switch it up a little bit. Let me put it over here. So what happens if I go 7/9 minus 11/12? I don't know what my session with 12 today is, but here we go. I'm all for it. Okay. So, what do we see? You need to find what the 9 and 12 have in common. Good. Some people saying divide by 3. I wouldn't divide by 3. I get what you're saying because 9 and 12 are divisible and you could make the fractions a little bit smaller. But what else does 9 and 12 have in common? Lucas is saying 36. Is he right? Tallin 118 says, ooh, okay. Or geez, like, try 36 for the denominator. 36, misopinionated. All right. So if I'm changing this, let's try 36. So if I do 36, I'm multiplying this first ratio by what? Okay, I got a couple people saying 4. I'm saying 12. Careful, Holly. So I can make this 9 into a 36. Okay. So I want to make it into a 36. All right. So if I do 4 times 9, that gives me 36. Can't do 12 as my denominator because we don't have a 12 in the 9 times table. So whatever I multiply the denominator by 4, I'm going to multiply the numerator by 4. Are we okay? So 4 times 7 gives me what? What would my new numerator be? Okay, how are we feeling? All right, there we go. There we go, Tracy. All right, there we go, Jay. Caitlin. All right, good. Excellent. Don't be shy, guys. This is a safe space. We're all going to learn from each other. Okay, if you're not sure what's going on, where are you getting 33 from? Oh, okay. All right, Ray, I see what you're doing. I got scared for a second, Ray. I was like, wait, what? Okay, we're back. All right, so now we need to multiply this side. 12 times what will give me 36? You know, I have these slight heart attacks once in a while, you know. So if I multiply my denominator by 3, that means I got to multiply the numerator by 3. So 11 times 3, my new numerator will be 33. Good, Carla. Oh, hey, Carla. When'd you sneak in here? I'm so excited I found you. Aw. Well, welcome. It's like it's going to be a negative for an answer. So, Jay, tell me, how do you know it's going to be a negative? Okay. Lucas is saying it's a negative 5. Yes. So 28 minus 33, that does give us an answer of a negative. So if we think about it, I have $28. I want to spend 33. So that means I am $5 short. Okay. And yes, Jay, the denominator will be the same at 36. Can we simplify that? Can we simplify negative 5 over 36? No. Okay. I know the yay was for earlier and then the no was for this one. Yes, no. The only thing that 5 and 36 has in common is 1. Even if you try to divide it by 1, you're going to get your original answer. Okay? Why do all the extra work? Just get right to it. All right? So how are we feeling? Go ahead and let's take a moment just to do a little mad tap. I know, shameless of me to say. If you want, mad tap. If you know of anyone that they need this. Maybe they're trying to get their GED. They've talked about going to the military and they just can't pass the ASVAT, the math part in the ASVAT. If you know of anyone that is going through that, someone that is a homeschool parent that is just like, I don't even know this, and they feel fearful to help their own kids out with math. Share the life. Share it with them. Okay, I'm studying for my ACTs. Awesome. Now, Jay, are you already taking Algebra 2? That's the question I want to ask for you, Jay. Okay. Is there any way to solve this? That is it. This math is a foreign language. Of course, math is its own entity. I'm in geometry and quantitative reasoning. Yes, I got my 19-year-old looking at this. Good. Yes. Okay, good. Because a lot of people, and this is the one thing that I'm going to share my understanding, is SATs and ACTs go all the way up to Algebra 2. So if you're currently in Algebra 2, there's going to be some components, and if say that you're going to take the test like next month, and there are some components of math that you haven't learned yet because they cover all the way up to Algebra 2. So I always, every time they do this whole PSAT in October, I always want to boycott it because I would have students that were already in my Algebra 2 class. And here's the problem. They haven't learned everything. So they're sitting down, taking a test they haven't learned. We're making them feel stupid. We're making them feel insecure about themselves. For what? And that's why I feel like the ACT and the SATs is really designed for those kids that took Algebra 1 as 7th grade, Geometry as 8th grade, and then Algebra 2 as 9th grade. That is the design of the assessment, okay? So when you go in there, there are going to be some things that we haven't been covered. If you're taking Algebra 2 right now, and you'll be taking the Acuplacer, good, Bree. And the same thing with you as well, because there's probably some stuff that you're taking because you're in geometry right now. So you haven't even taken Algebra 2 yet. So the Acuplacer goes up to and including some components of like pre-calculus, okay? That's how I felt with the PSAT. Yes, because it's like I was so upset with my score. Exactly, because you weren't in that realm. So don't feel bad. You know, you're going to make it through. You're still going to be a successful person. So please don't let this beat you up. This test does not define who you are. You're definitely intelligent. So please, okay? Thank you so much. I appreciate that, okay? So when we're doing this math, take your time and we're going to try to do the best that we can, okay? But I feel that, so I have to retake it. Okay. And there's nothing wrong with retaking it because probably the way it was presented to you, Bree, was completely different from, no one prepared you. They all basically said, oh, you should know this. Well, guess what? We had something called a pandemic, guys. And there was a lot of stuff like during the pandemic, you were like sitting around in your pajamas on your couch, watching whatever, eating Cheetos, and you were kind of paying attention. And most of the time the teacher wasn't really teaching anything. So yeah, you didn't learn how to, do step by step. You didn't learn how to simplify and add, subtract fractions. So now you're sitting in the class and you're freaking out. So right now, we're going to take it and we're going to go through it. Okay. I have it in April, so I'm studying. Okay, cool. Okay, good luck to you. Yes, you got this. All right. So look, all these people are supporting you. Isn't that awesome? This is awesome. I love this. All right. So I am going to put a little bit more. I'm going to add to this before we move on to the next piece. So what I'm going to do is I'm going to put, and they always have a question like this every single blessed time. They have 1 4/5 plus 11/15. What is this? And I forgot basics. Oh, it's relearning. Yeah, and that's fine. And that's fine. And then by you understanding some of these clinically clever, it's going to come up. And then your child's going to come up with this and you're like, hey, I figured it out. Let me show you. Okay. Hey, Mrs. Wall, how are you? Tez, when'd you sneak in here? Look at y'all. You have to make the mixed fraction improper. Yes. How do I do that? All right. So we have a rhythm and a lot of people generally get it mixed up. So first off, we have to multiply. And I'm going to put a dot here because multiplication now does not mean an X. Stop it. So you multiply the denominator with the whole number. We're going to get an answer. Then we're going to take that answer and add it to the numerator. So 5 times 1 gives me 5. 5 plus 4 gives me 9. And we put it over the same denominator. Let me know if I have to break that down again. I know, and that's why I'm doing it this time. So you thought you were slick, Miss Wall. So didn't I tell you I hate fractions last time? I know you did. Hence, that's why I'm doing this. All right. Good, Jay. So multiply the 1 times the 5 and then add the 4. Yes, and don't forget to put it back under the original denominator. So now I'm going to bring down my plus 11/15. Remember what we said when you're adding and subtracting fractions. We need to have what? Could we break those down? What do you mean, Emmanuel? Break what down? I think I have an understanding, but I wanted you to clarify for me. Because this can go one of two ways. There's probably a third way, but I don't want to go into that far. Okay, we need a common denominator. Yes, Judas. Hello, Lynette. When did you sneak in here? I gotta learn to look up. Okay. All right. So we need to have the same denominator. Yes. Okay. Oh, yes. It's 15. Yes. So we could, the common denominator, a lot of people will be like, all right, 5 and 15, you could use 30. But the least common for 5 and 15 will be 15. I still don't know how to make the bottom the same. Okay, so we have to think of our multiplication table. So we have, in the 5s, we have 5, 10, 15, 20. In the 15s, let me put it over here. So the 5 times table, we have 5, 10, 15, 20, 25, 30. I'm going to stop at 30. I'm going to move this over so you can see. For the 15 times table, we have 15, we have 30. I'm going to stop right here. So yes, they both have 30 in common, but they also have 15. And 15 is the least common. So when we're looking at this, all we have to do, this one already has the 15. So if I want, I could just bring that bad boy down. But this one, we need to change that 5 to a 15. And by doing that, what times 5 will give me my 15? And some people said 3. Yes, Holly, I see you. So if 3 times 5 gives me 15, whatever I do in the denominator, I have to do in the numerator. So 3 times 9, that gives me 27. Okay. So why did I have to become 9/5? I'm not sure. Why did you have 9/5? Oh. Let me see if I understand what you're saying. We had to turn it to improper fraction. Oh, okay. So why didn't we just multiply 4/5 times 3? Well, we needed to have a common denominator. Okay, so the reason why we're multiplying 4/5, well, hold on. We had to change it. There we go. I had to look at the original equation. We had to change it from a mixed number to an improper fraction. Once we change it to an improper fraction, then we're looking for a common denominator. So when we got our common denominator, now all we have to do is add these two together, but keep the denominator. So what's 27 plus 11? Okay, I'm back now. What'd I miss? I don't know when you left. Sorry, Lucas. There you go, Lucas. He's like, I just jumped on in here. Good job. All right, so we have 38/15. Okay. Yes, so make it improper first, and then let's tackle the denominator. Are we okay now? Because I'm doing and I'm popping up and trying to look at the same time, and sometimes you guys ask questions and it's just like, oh, it's already been answered. Okay, what type of math is this? Well, I'm going to say that this is foundational. Foundations of math. So this is just basically adding fractions. You're so welcome. Okay. It's like, I'm going to get going. Not a problem. Thank you for stopping in, Ray. We'll see you next time. We'll probably see you tomorrow, okay? Either 1 p.m. Eastern Standard Time or 8:30 p.m. Eastern Standard Time. All right. So someone say 5th grade. Now, here's the thing. I always don't like to choose it by grades because there are some kids that are doing this in 7th grade. There are some kids that are doing, that's in honors, that's doing in 4th and 3rd grade. So, yeah, I just want to say it's foundational math. Alternative fraction improper. Got it. Awesome. Good. If we try with 30, will it be the same answer? All right. Well, let's see. So we broke down. Let me use my pencil. So we broke down the fraction and we got 9/5 and we got 11/15. If we wanted our denominator to be 30, that means we're going to be multiplying this side by 2. And we're going to be multiplying this side by 6. So you'll have your 30 and our 30. So we got 22. Here we got 54. So since it's going to be over 30, 54 plus 22, that is 66. No, sorry, 76. And then we want to figure out what we need to reduce by. So since both of them are even, I know I can definitely reduce it by 2. Okay, so if I reduce it by 2, I got my 15 as my denominator. This will be 3, that'll make it 16, and there'll be 8. So you will get the same exact answer. Let me shrink it up a little bit so you can get in there. Okay, so you'll get the same results. All right. Oh gosh, what's wrong? All right. So I just see, oh gosh. All right. So knowing you'll still get the same answer. If you wanted to claim both of the denominators, you can change it to 30. Or if you just wanted to replace just one of the denominators with the 15, you'll get the same answer, but it'll just be more work. All right. All right, if there were odd numbers, would you reduce them by a different number? Most of the time, if they're odd numbers, you might want to reduce them by 3, see if that's working. And if that isn't working, you guys got 3, you got 5, you got 7. But anything after 7 generally tends to be just factors of 1. Okay, but you can give it a try. No thanks on the more work. I know, I got you. All right, so that is adding and subtracting fractions. Okay, so if you want to take a look at the rules, I always like to have little steps here. So we got our formulas. If they have a common denominator and you're adding, you're just adding the numerator. If you have a common denominator and you're subtracting, you're just subtracting the numerators. And then if you want to take a screenshot of the steps, just in case you need it, here's the steps. Okay, you gotta look in between to see what the operation is. Find your least common multiple, okay? Then you want to combine your numerators, but keep the denominator. All right? Okay. So I'm learning math again to help her with her homework. Yes. Okay, this is insanely helpful. Not a problem. Okay, math is so complex, but I love it. I know. It's like a slow burn. Oh, wait. Gotta do this whole moving of the puzzle piece. All right. I already told these people I'm going to be on here for a while. Okay. All right. So that's fractions. Get rid of that. All right. So that's adding, subtracting fractions. Now multiplying. This is when it gets somewhat different. Okay. This is when you do not have to have a common denominator. Adding, subtracting, common denominator. Multiplying, dividing, you don't need a common denominator. All right, so if I said, for example, I have my 5/8. I usually do this in my book, but I have my book set up for tomorrow. This was, again, just a prompted thing that just came up. So we have 5/8 times 3/5. Okay, 5/8 times 3/5. We can tackle this one of three ways. Okay, so one of three ways. One of the ways is we can just multiply straight across and then simplify. So if I wanted to, I can multiply 5 times 3, which gives me 15, and 8 times 5, which gives me 40. So I notice my numerator ends in 5 and my denominator ends in 0. So that means I'm dealing with multiples of 5. So if I want to, I can divide, because I'm simplifying, by 5 in the numerator and divide by 5 in the denominator. Okay, because I wanted to simplify my fraction. 15 divided by 5 gives me 3. 40 divided by 5 gives me 8. So that's one way of doing it. Either you can multiply straight across and then simplify. All right? Here's another way. Let me change pens or pencils. So if we have 5/8, I'm using the same numbers, times 3/5. I can simplify and then multiply. Okay? If this is when you do on diagonal, yes, Danielle, this is exactly when you do in the diagonal. Yep. Okay? So now, if you notice, right here on the diagonals, I'm going to dot it out. Right here on the diagonal, I have 5 and 5. There's a 5 in the numerator, and there's a 5 in the denominator. Let me clarify it up a little bit. This is the same, if I may put it to you this way. This is the same as me writing out 5 times 3 over 8 times 5. Right here, 5 and 5, they can cancel out or give me 1, because 5 divided by 5 gives me 1. Okay? I'm doing what's called cross-simplifying. So since I know this whole number of 5 divided by itself will give me 1, now I can multiply straight across. 1 times 3 gives me 3, and 8 times 1 gives me 8. So what I did was I simplified, then I divide. The first one I multiplied, Then I simplified. Okay, this is what I was helping my nephew with. He's struggling heavily with multiplying and dividing them. Awesome. Okay, no way. That's so easy. Yep. I know. I mean, I can throw out some complicated terms if you want, but it's basically that. That's all it is. You're either doing one of the two. Always look to see if you have something that you can simplify. You simplify or you divide them, and then you multiply the rest. All right, so let me do another one. So let's say, so we have -7/9. Yep, she had to throw a negative in there, didn't she? Yes, she did. And then -5, let's say 21st. You're probably hearing my cat losing his mind. It's not time for dinner yet. But you can tell when it gets kind of close. All right. Since we're multiplying, first thing first. A lot easier to understand now. Not a problem. So we have a negative. Let me see if I can zoom in a little bit. About that. So we have a negative times a negative. What's a negative times a negative? You can either put the symbol or you can type the word. What's a negative times a negative? Okay, Danielle saying positive. Hey, Lizzie. Okay, Cash Boss says positive. Odell positive. Tracy positive. Okay, Kiki positive. Yes. Okay. And it's so funny, if I may. We have those stuff memorized, and sometimes we totally forget to bring it down. I can go to a student like, what's the negative times the negative? Positive. Like, not even a pause. But then I'm like, look at your paper. And they're like, oh, I forgot. Okay. So it happens. So we know our answer is going to be positive. So now take a look at your diagonals. Are there any numbers that we could simplify? Okay, Cash is saying cross simplify. Yes, but when am I cross simplifying, Cash? The 7s. Yes. Okay, so I got my 7 and I have my 21. Okay, so they both have what in common? What do they both have in common? Okay, it can go into 3, Danielle. Okay, it can go into 3, not 2, not the 3s. You'll get 3 as a result, but what they have in common is 7. Okay, because if I do 7 divided by 7, this is going to now be a 1. If I do 21 divided by 7, that's what you guys are seeing. 21 divided by 7, that's a 3. Okay, we're good now? There we go. They're both factors of 7. Thank you. All right. So now we know our answer is going to be positive. So now let's just multiply. So 1 times 5 gives me 5. 9 times 3 gives me 27. So now I'm looking, 5 and 27, the only thing they have in common is 1. So that means this is my final answer. Okay, how are we feeling? Okay, seeing some hearts. That means you're still alive, which is good. There is still a pulse out there. Good, good, awesome. Okay, give yourself some praise, guys. You're doing math on a Sunday night, voluntarily. Like, no one's like, you got to come to this live, you know? Yes, you're doing it. Yes, do it up, dance it up, celebrate. All right, good. I was going to say 5/27s, but we're breaking the whole answer down. Yes. Okay, nice job. All right, so this is basically it when it comes to multiplying. You're doing one of two things. Either you're multiplying straight across and then simplifying, or you cross simplify and then multiply. All right, I'm going to give you one and you're going to give me the answer. Let me see if I can make it just. Let's see. What kind of concoction can I draw up? Okay, I could do this one. How about 2/3? I'm going to do it like this one. Times -9/16. Ooh, she doing something fancy. Okay. Let's see what we got. Grateful for you finishing up my math GED study and I need the extra help. Not a problem. That's why it's here. Thank you for the follows as well. You got this. Yes. Love that. Yes, keep encouraging. I love it. All right, so 2/3. And so don't put your answers down just yet. Just hold it for at least like a minute. So what's 2/3 times -9/16? I'll let you know when to flash them up, okay? Hello, Kat. Welcome in. I got it, but I'm not going to put the answer. I appreciate it, Lucas. I know it's like itching at you. Like, I just want to put it up there. Okay, we're almost done. Almost ready to put it up there. Almost time. Okay. All right. Rain down your answers. Put it up. Go ahead. Put it up. Let's see what you got. Got a -9/24. We got 3/8. -3/6. 3/8. I'm doing mental math. I don't know. Hey, I love the fact that you're doing mental math. So -9/24, -3/8, -1/2. We got a nice little mixture of answers, but I appreciate everyone's putting stuff up. This is awesome. We got 3/8. We got -9/24. Mental math may not be my strong suit. You have no idea. You might be right. Okay, so -3/8, -3/8 simplified, -3/12. I have no idea. Not a problem. I'm going to break it down in a moment. So -1/2. All right. Give me one more answer if there's one more person. Okay, Holly, we've got -9/24. All right. So now we could multiply straight across, then simplify. But I always like to do a check. We have my 3 and the -9. They can be simplified. So if I think of it, 9 and 3, they both have 3 in common. So 3 divided by 3 gives me 1. -9 divided by 3 gives me a -3. But guess what? Because I like to be sneaky. We have 2 and 16. So they can be simplified. So what 2 and 16 have in common is 2. So 2 divided by 2 gives me 1. And 16 divided by 2 gives me 8. So now everything is simplified. Let's multiply straight across. So 1 times -3 gives me -3. And 1 times 8 gives me 8. Now, for those that had negative, I'm going to put it over here. I think it was -9 24ths. All you had to do was simplify this. What number does 9 and 24 have in common? 3. So we just had to take it one step further. So this gives us our -3 over our 8. So either way, you would get your same answer. Okay, I have to scroll up because I was chatting. All right, so, oh yeah, okay, I completely ignored the negative sign. All right, 6 in common. Okay, we can do that. Okay, I did 2 and 16 only. We can do both. Yes, you can. Yes, you can. Anything that can be reduced and they're reduced by the same number, yes, you can. I did it the long way. Not a problem. Nicole, that's fine. Guys, you guys got to understand, and I think that's what happened to the education system. And as a former teacher, I would like to apologize that there is more than one way to get the same answer. Okay? So for those teachers that made you feel like you have to do it one way and one way only, I would like to apologize for them because there is multiple ways of getting the same answer. Okay? So it doesn't matter which diagonal you start with. No, it does not. I didn't put the negative sign. Okay. I only did 2 and 16 simplified. Didn't know we can do both from the start. Yes, you can. Yes, I forgot. No problem. You guys are stressing yourself out thinking that this is Squid Games or something, like we're about to knock you off or something. You're not going to die. It's okay. Take a breath. Because it feels like magic, no joke. In so many ways, no way is wrong. Thank you, Lucas, for reiterating that. Yes, thank you, thanks. I took the 8 and simplified to a 4. Okay, Squid Games, I know, right? Next thing you know, I'm going to send everybody a cookie and just be like, okay, I want you to take out the pie. The pie symbol out of the cookie. My goodness. All right. I know, we as teachers just make it feel like it's life and death, and it's not, all right? All right, so how are we doing with multiplying? Okay, as long as you keep simplifying means breaking down the number, yes, Holly, that's what it means. You're breaking it down to its lowest term, all right? L Boogie, how you doing? All right, no problem. All right, cool. So, that's multiplication. Now division. I'm going to put this in pencil. So when you're dividing, a lot of people get a little too crazy with this because they're like, oh, okay, I have 3/8 and I want to divide 3/8 by 3/4. Okay. This looks crazy. No, just no. Altogether, no. Where are you going to start? Where are you going to end? Where are you going to follow? And I know some teachers are like, no, the kids need to learn it this way. No, you do not. Okay? The thing that you need to understand when you're dividing, you're going to keep this numerator. So I'm going to make my 3/8. Instead of division, let's change it to its inverse. And the inverse of division is multiplication. So I'm going to put parentheses. Then this denominator, 3/4, what I'm going to do is I'm going to flip it so it can be on the same level as my 3/8. So that means I'm going to flip 3/4 to 4/3. So basically, when you're dividing, instead of a fraction with a fraction line with a fraction, this looks crazy. Change it from division to multiplication. Okay, so it's almost like you want to say keep, change, flip. Okay, KCF. I know when we usually do subtracting polynomials, we had K of C. But we can do KCF. No matter what, it's Kentucky chicken. All right? Right, so we are going to flip the right fraction and we change it to multiplication. So now I'm seeing some answers of 1/2. Look here on the diagonal. We have 3 and 3, so they can cancel out. 3 divided by 3 gives me 1. 3 divided by 3 gives me 1. Now I have 4/8. So with the 4/8, what number does 4 and 8 have in common? Yes, look at all these 1/2. Look at all these brilliant people. So we're going to divide it by 4. Okay? 4 divided by 4 gives me a 1. 8 divided by 4 gives me a 2. So now multiply straight across. 1 times 1 gives me 1. 2 times 1 gives me 2. So when I divide 3/8 divided by 3/4, my answer is going to be 1/2. Okay. I'm seeing some 4s and I'm seeing some 12s. If you wanted to multiply straight across, you can do that, guys. If you want to multiply straight across, it would have gave you 12 24ths. Then you can divide it by 12. 12 divided by 12 gives you 1. 24 divided by 12 gives you 2. So you'll get the same answer. Even if you divide it by 6. I'm going to give you the whole span. So if you have your 12 24ths and you reduced it by 6, this gives you 2 4ths. And 2 4ths also gives you 1/2. So no matter what, you're going to get that same answer, final answer of 1/2. Okay, I'm gonna cry. I'm gonna call my mom and tell her I can do fractions. I'm almost 40, but still, exactly. Let me tell you, Nicole, dead serious, pure honesty. I hate it. I used to suck at math, like completely suck at math. And it took this one teacher. I was working as an assistant, instructional assistant for special ed students at a local high school. And this teacher said, fractions is nothing but division. And it almost like something just kind of like the clouds opened up and you hear the singing and all that stuff. And that's when it all hit. I was like, oh. And I totally got it. I was 25. Had a grad, had my bachelor's degree, played professional overseas, came overseas, wanted to coach, had to be on staff, blah, blah, blah. And yeah, that's what I did. It's like, girl, I'm almost 47 and giggling at how proud I feel. I love this. My high school math teacher gave me yes, and I struggled with math until I met you. I love you. Oh, thank you, Holly. I appreciate that. It's like, that's all I wanted to do. Just relax. Like, call her now. Put her on the phone. Give her proof. This is awesome. So yeah, like that's all you're basically doing, okay, when you're dividing. So let me give you one more, and let's see if you guys can get this one. So I have -5, 6, -5, 6, and I'm going to put it in this traumatic phrase, okay, over -8/10. All right, so see if you guys can do that one. Let me pull down the previous one. I think we can see both, so you can use the first one as a guide. I might have to shrink it in a little bit. Okay, so at least you can use it as a guide. Use the first one that we did as a guide to solve the next one. Aww. Okay, so we have 25 over 24. We have 1 1/4. Radians. Check your denominator radians for the 1/4. Okay, there we go. Well, no, get rid of that negative. You're right with that. Okay, Lucas. And don't let other people's answers make you change your answer. That's another thing. Because most of the time, your primal instinct is usually right. Okay, so we got that from Nicole. Hey, Kent. Okay. All right, so we start off with our numerator. So negative 5/6. So we're going to keep that. Change from division to multiplication. And then flip the other one. So we got negative 10 over 8. Okay. So with the 5 and the 8, the only thing they have in common is a 1. So that's not going to work. But the 6 and the negative 10, they have 2 in common. So if I take this 10 and divide by 2, I'm going to have a negative 5. Take this 6 and divide it by 2, I'm going to have a 3. So now, multiplying straight across. A negative times a negative gives me a positive. And 5 times 5 gives me 25. And 3 times 8 gives me 24. So you could leave it as 25 24ths, but if you want to make it into a mixed number, remember you're going to be dividing. $25 is your dividend, 24 is your divisor. How many 24s can go into 25? Just one. Bring down your 24. And we're always subtracting. 25 minus 24 gives me 1. So 1 is my remainder. And I think it was radians I was saying. There you go, radians. I see it now. Good. So you got your remainder over your divisor, which will be 24. So you either can leave it as 25 24ths, or you can have 1 and 1 24ths. Excellent job. And I wanted to say, Bridget, take the question mark off the end of your answer. I was like, no, I didn't want to give it away. Just saw where I messed up. I kept the negative 8 instead of negative 10. Okay. All right. I got it right. Woohoo! Yes! Good job, guys. Look at you guys. I love this. It's bringing me so much joy. I was second guessing myself. I know. And that's the one thing, like as you're getting older and you're starting to experience math, one, there's no stress. You don't have to worry about passing a test unless you're making this association with your current classes. Okay. But in this atmosphere, we're chill. You know, we're relaxing. You don't have to worry about high school drama. Who said this? Who said that? Who's dating who? Who's recycling? You know, all that fun stuff. So never your answer is usually your correct answer. Yes. Right? So it's kind of like just take your time with it. All right? So that's multiplying and dividing fractions. That's it. So if I may slide over just for a minute, can we get smiley faces on our papers? Let's see. Here we go. Nice little circle. Dun, 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 dun. Yeah, look at my Picasso. Do, 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 do. Ta-da! So I'm bald-headed. That's fine. We did it, class. We did it. It's so funny because everybody's like, oh, you know, teenagers, people don't like stickers. Please. You treat teenagers with respect, but they love stickers. I mean, it's like an obsession, all right? I used to have a stamper, but like boom, 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 and I did all the stampers. God forbid if I miss a stamp. God forbid. You think I like sold their puppy to the mill, all right? But nice job, guys. All right, so we have a couple of things. So I want to say you have a choice. We either want to do decimals or you want to tackle small introduction to word problems. I was trying to do it because I thought it was. All right, so put in your decimals or word problems. What would you like to do next? Well, we're going to do both. I just want to know what you want to do first. Like, I didn't say we're going to get rid of one. I just like to say, what would you like to do? Let's see the notes, please. Oh, okay. Well, the notes for fractions. Here you go. Okay, multiplying either straight across and simplifying. Or when you're dividing, you do your keep, change, and flip. So if you want to take a screenshot, you can for that. Okay, I dislike both. Of course, that's why I have both of them, Lucas. Okay, decimals, word problems, decimals. All right, looks like we're going to do decimals next. All right, and then this was the other steps for multiplying and dividing fractions. So if you like how my page is set up, I actually created, like some of you guys probably already know, I actually created a math notebook. So this is my math notebook that I usually keep like all my notes, all my math stuff. Let me see. And I just got tired of kids not having a notebook. And especially this is designed for math because one side I got the dots and the other side I have the grids. I'm kind of loving the dots. The reason why I'm doing this because I'm already got things set up for Monday and this was like an impromptu thing. But in addition to these, I have my factor sheets. I also have the rules of integers, word problems, which actually I'm going to show you guys this in a moment and probably going to have you take a screenshot of it. But we're going to look at these different operations. The words has like the order of operations. We also have the properties of exponents, linear equations. It has like all these different rules. Hey, no problem. So I have like, I just basically created this because after a while, I just got really tired of my students not having organization and it was making me crazy. So if you're ever interested in that, I do have it available on Amazon. But just for tonight, we're just going to go with this spiel. All right. We're going to do some rounding and adding and multiplying decimals. And it was lovely. Thank you, Bridget. I appreciate it. And it seems like a lot of my students are able to organize their thoughts a little bit better. I do have one. The one I just showed was for 7th through adults. So anyone in pre-calculus can use it. I'm always trying to revamp and add in some more resources in the back of it. But I do have one for 4 through 6. And 4 through 6 usually does a good job with doing the placement. Now, because we don't write checks anymore, okay, that is a problem. It's really sad that we don't write checks anymore, because this decimal point kind of splits things into two separate worlds. We're dealing with the wholes, and then we're dealing with the THs, the th at the end, okay? So when it comes down to, oops, am I getting that? What is the book on Amazon? So the book's on Amazon called The Ultimate Math Notebook. If you type in my name, which is the profile name, Audrey Codner, you can actually see all my notebooks, and I have like coloring pages and all that kinds of stuff. So all that's on there. All right. So when it comes, let's clear that up. There we go. So when it comes to the wholes, okay, we got our ones, our tens, our hundreds, our thousands. This is how we want our bank accounts to look, right? On the increasing level. So we want those papers. We want, we want that dollar. We want that $10 bill. We want those hundreds. We want the thousands. We want 10,000s. We want to keep going, right? But to the right of the decimal place, we're taking basically the change, what's left over. There is no such thing as once, okay? Stop it, okay? It doesn't exist. So the lowest we got is our tenths, our hundredths, our thousandths, our 10,000ths, okay? We're used to seeing things up to the hundredths. So something out of 100. So if I say 20 cents, 20 cents is basically 20 out of 100 pennies. Okay, this is what a decimal is. 20 cents is completely different from 2 cents. Okay, so 2 cents is 2 out of 100 pennies. Okay, there's a difference between 20 cents and 2 cents. And it all depends on where the 2 lies. So in this one, the 2 is lying in the 10th spot. Here, the 2 is lying in the 100th spot. Okay, so actually that should be 2 out of 10s. Sorry, I got excited. Should be 2 out of 10. There we go. Probably someone corrected me. I hope so. If not, I'm so sorry. Tell I'm starting to get loopy. All right. Okay, I need it. What's the name of it? Oh, the name of the notebook? The Ultimate Math Notebook. If you just type in, if you go to Amazon and you type in Audrey Codner, AudreyCodner, you'll see all my books listed. Okay, and there's 2 that there's this same book, but it has 3 different covers. Okay, but it's the same content. I just wanted to change up the covers because I wanted to be special. I don't know. I was just feeling myself. Just wanted to get a little variety. Okay. So decimals are fractions, fraternity twins. Yes. Yes. That's the best way to describe it. I love that. All right. So when you are going into it and you're going into the rounding of it, so a lot of people just don't know where to round. Most assessments will round to the 100th spot. So if you want to round something to the hundred spot, you need to look at the next slot, which is the thousandths. So let me give you a couple examples. So let's say, I know, kitty. So let's say that I have 101 and 467. Okay. Say that I want to round this to the hundredth, TH at the end. Got to emphasize that. All right. So I have to round it to the hundredth position. So that means I need to get my eyes on the thousandth position. So the rule is, if it's 5 and above, we're giving it a shove. If it's 4 and below, we're going to leave alone. I think you guys can see that. Okay. All right. So we're looking at the thousandth position. So since it's a 7, that means, and it's bigger than 5. So that means I need to add 1 to my hundredth position. So my actual answer is going to be, the 101 stays exactly the same. The 4 stays exactly the same. But now that 6 turns into a 7. Helps when I see them as similar. Yes. Okay. So that's basically what's happening. So some people just don't know. Like, okay, I need to go to the 100 spot. So they'll stay at the 100 spot and say, oh, well, my answer is going to be 0.5. No. If I say 0.5, that means I'm rounding to the 10th spot. You have to look at the previous one, see what's going on here. If I need to add to the next spot, you can do that. Okay? So if they say round to the 1000th spot, I need to look in the 10,000th spot. If they say round to the nearest tenths, that means I need to look at the 100th spot. If they say round to the nearest tens, I need to look at the ones spot. If they say round to the nearest hundreds, I need to look at the tenths spot. Does that make sense? Hello, Miami Heat. Okay, are we okay? All of a sudden, there was like a pause. It's like, okay, there's some hearts. Are you still alive, my children? Did I blow your mind? Is it too much? Talk to me. Okay, so you got 100. Good. For Nicole. Okay, hey, Kenya. I just saw your thing. Nope, we're with you. Okay, all right. Got it. All right, good. I know, it was just like there was no hearts, there was nothing. I felt like it was a deadline. I'm like, no, don't. Kind of processing. That's fine. That's fine. I'd rather you be processing, and that's fine. Good, just listening. Okay, got you. All right. Okay. So let's see if I can do another one. So if I say, let me bring it over here. So we got this example. Let's say if I got 1,768.49. Okay, I'm going to use this number a couple of times. Okay, got it. You're coming for my numbers. There's like a little competition going on here. All right. So we have 1,000. Again, let me get my zoom on. Okay, so we got 1,768 and 49. Okay. So if I want to round this to the nearest tenths, no th at the end, nearest tenths, what would my answer be? If I'm rounding to the nearest tens. Okay, Bridget's saying it's 1770. Okay. Native saying 1770. Odom is saying 1769. So that means we're rounding to the tens. So Nicole 1770, Cole House 1770. Clinical Clever 1770. Okay, so if we're looking at the tens, we want to round to the tens, so that means we need to look at the one spot. So my one spot is an 8. So that means 8 is 5 and above. So I'm going to add 1 to the 6. So that gives me 1,770. Okay, I'm lost. Here we go. Oh, wait. I rounded to the tenths. Okay, yes. All right. So if you're rounding to the tens, you need to look at the previous spot, which is the ones. So if it's 5 and above, if it's a 5, 6, 7, 8, 9, right? That means we're going to have to add 1 to the spot that we want to round to, which is your tens. So that's why it'll be 177. But we need to still represent that it is in the thousands. So that's why we had to add the 0 to the end. Okay, we got rid of the 8. So we can add the 1 to the 6. And the 8 doesn't exist, but we need that 0 as a placeholder because we want to keep it as 1,000. Okay. So if I want to round to the thousands, no th, same numbers. If I want to round to the 1,000, where the four, right. So if I want to round to the tens, after the decimal place doesn't exist anymore. It's gone. It's not part of it. So like if I had $1,768 and I want someone to round it up for me, they're not going to give me my 49 cents. They're just going to round it to, okay, let me round it up for you. That'll be a $1,770. Okay. So like if I had, say I earned this and someone says, okay, let me round it up to the nearest thousands, that means I'm looking at the 100 spot and they're going to add 1 to the 1. Okay. Okay, I get it. Good. Makes sense. So I got a couple people with 2,000. So Clinical Clever, 2,000. Bridget, 2,000. Odom, 2,000. Okay, so always kind of think of it like money. I always like to do that way. Just think of it like money. So this will give me 2,000. All right. So same numbers, but I want you to round to the hundredths with the TH. With the THS. Round to the hundredths. What would it be? The hundreds with the TH. So not 100 with just the S, the THS. Okay. So if we're looking at the hundreds, what spot should I be looking at? Okay. Give me 2 more answers. Okay. All right. So if I'm looking at the 100th spot, that means I need to look at the thousands. What's in the thousands with the THS? Do we have a number representing the thousandths? No, there's nothing there. So it's almost like there's like a 0 if I put a placeholder there. So technically 0, yes. So, we don't have it, right. So that means if I round this to the hundredths, it's gonna be exactly what it is. And the person that had it was Bridget. Okay, so basically it doesn't move because we don't have anything. Remember, if it's 4 and below, we leave it alone. Sit, look at the celebrate. I know, tricky, I know. She's like, tricky. Right? So if we want to round to that spot, that means we need to look at the previous one. 4 and below. Yes. If it's 4 or below, you leave it alone. 5 and above, you give it a shove. 4 and below, you leave it alone. All right. Okay. If I want, I'm going to take, this is the last one. All right. So this is the last one. Same numbers. But I want you to round to the tenths with the THS. What would it be for the tenths? Same numbers, but to the tenths spot. Yes. If it was 5 and above, yes, you will make it 0.50. What will we get if I round to the tenths spot? Okay, 2 more answers, 2 more people. Okay. Caitlin, Mark. Yes. So, rounding it to the 10th spot, that means I need to look at the hundredths, which gives me 9. So, 9 is 5 and above, so I'm going to add 1 to the 4, which does give me my 1,768 point, you could say 0.5 or 0.50. All right. All right. How we're feeling? Okay. Hey, Lynette. Oh, we were looking at the 10th spot. The 10th spot. All right. Okay. That's rounding. How we're feeling? Better? Good. Not a problem. Class is great. Not a problem. Yeah, I'm still doing here. I might not have a voice tomorrow, but I'm still here. As long as you guys are still here, I am more than willing to be here. All right. So now, real quick, one thing that we definitely need to know. If I want to, and if you can go ahead and tap for me, I would greatly appreciate it. I would love to have like 10K. That's just me. It's me being selfish. I'm sorry. Going live is addictive. I know. I haven't left because I really wanted to get this done. And then plus with me having my kids cancel on me, I was like, okay, I need to distract from my sadness. So, but at the same time, I'm like, hey, I can help other people out. So let me come on and do live. All right. Oh, you deserve $1 million. I appreciate it. So if anything, when you are adding decimals, adding and even subtracting. So like if I said $724 and let's say 51 cents, and I want to add like $57.81, right? Make sure your decimals are lined up. Okay, when you're adding and you're subtracting, you make sure your decimals are lined up. And then we just basically combine as we go through. 1 plus 1 gives me 2. 5 plus 8 gives me 13. And we carry the 1. Bring down the decimal point. All right, so 4 plus 1 is 5. 5 plus 7 is 12. Okay, 1 plus 2 is 3. 3 plus 5 is 8. And then I just bring down my 7. Okay, so when you're adding, subtracting, you have to line up your decimal points. Okay, thank you. I appreciate that. I love that. My daughter taught me that decimals have to line up for adding, subtracting. Yes, see? Brilliance. Now, here's the thing. When it comes to multiplying or dividing, they don't need to add up, okay? But this is what a lot of people do. So let's not get too technical. So like, let's say 25 and 7/10 times, let's say 600s. And we're multiplying it. I hate to do the symbol of X. Cringe, but this is multiplication. All right. Now, with multiplication, they do not have to line up. Still here, just eating while learning. Hey, not a problem. Look, do what you gotta do. Now, the one thing that we need to know is we're going to multiply, almost like distribute. Okay, my last term, I'm going to distribute to everything up top. So I'm going to do 6 times 7, which gives me 42. So I have my 2, and I carry over my 4. Now 6 times 5, that gives me 30. But I have to add the 4, so that's 34. So I bring down the 4, carry over the 3. Now 6 times 2 is 12, plus 3 is 15. And I can bring down the whole 15 because I don't have another number to carry it over to. All right? Now, you can do the same thing with the 0, but we all know that anything times 0 is going to be 0. But if I go to my 10th spot, that means the answer of the 10th spot should go in the tenths of the next number. I know they're doing something funky in schools. They're doing something like a little bit of Singapore math or, what else is it called? They're doing all kinds of funky things. And they have like the kids put a 0 underneath and all. It's fine. But no matter what, since I'm in the 10th spot and I multiply by 7, I get 0. I got my 0 times 5, that's in the next spot, that's 0. 0 times 2, that's 0. Once I distribute all that, you're basically adding these two together. But we all know anything adding to 0 is basically its original answer. So we got 2, we got 4, 5, and 1. Then the kids leave that as their answer. Yeah, that new math. We all know about that new math. I think most parents are like going through therapy because of the new math. That's what my 17-year-old calls it, right? Now, this is not your answer. That's not your answer. The reason why we need to bring the decimals into it. So if we take a look, the first number has 1 decimal place. The second number has 2 decimal places. So that's telling me that my answer should have 3 decimal places. Okay? So it should have 3 decimal places. So when you're multiplying, you're basically adding how many decimal places that you have. We always start all the way at the end. We're behind the 2. And then we're going to move it over. 1, 2, 3. So my final answer should be 1 with the decimal, 542 thousandths. Talk to me. I can't do long division in new math. It makes no sense. I need Miss Audrey for that nonsense. I got you. I think we did. Did we do long division? We did do long division. Last week. We did do that. I'm going to see if because I haven't gone through my video recording of that. I'm going to see if I can cut up small chunks and put that on TikTok. What if the second number has more than 1 decimal? You count up how many decimals it is. So like if you had like say 4 decimal places here, like if you had like 4 actual, like say a 2, 3, 7, let me actually put it down here. So say if I have 1,700 and I don't know what me and the 7s are, and 34. So I'm going to say that's like 17.34. And I'm going to multiply my decimal point of 261. Let's see if you guys can see that. Okay. Okay. No comma. Oops. Yes. No comma. So this is a decimal place here, and this is a decimal place here. This has 2 decimal places. This has 3 decimal places. So that means my final answer should have 5 decimal places. Okay. What days do you come on live to teach this? Oh, please do. Okay, yes, I'm definitely going to do the videos things. What days? Monday through Friday, I'm here at 1 p.m. Eastern Standard Time. And then Monday through Thursday is at 8:30 Eastern Standard Time, p.m. Because I just got a client for Fridays, so I'm sorry. All right. Is that the original number? Yes. Yes, Holly. So 0.261 is the original. I'll put a 0 in front. I do have a habit not putting zeros in front. I know, bad influence. Okay, so don't freak out. So we're going to do this. We're going to have 3 rows. So the first one, we're going to deal with the 1. So 1 times 4 gives me 4. 1 times 3 gives me 3. 1 times 7 is 7. 1 times 1 is 1. Are you okay so far? Okay. All right. So now, don't worry about the decimals until the end. So now we're going to distribute 6, because now we're in the 10th spot. So it's 6 times 4. That gives me 24. So I'm putting my 4 down underneath the 10 slot. and I'm carrying the 2. Actually, I should have done that in pencil so you can see the difference. And then carry the 2. So now 6 times 3 is 18. 18 plus 2 is 20. So I'm taking down the 0 and carrying over the 2. Okay. I still multiply the old way, so I'm learning a new way today. Okay. So now if we have our 6 times 7, that's 42. 42 plus 2, that's 44. Bring down the 4, carry over the 4. So now 6 times 1 is 6, plus 4 is 10. So since I don't have a 1 to carry over, I'm going to put my 0 and I'm going to put my 1. So now, I got to get myself some pens. So now we're going to take care of the 2. So the 2, that's ones, that's tens, that's hundreds. So that means my answer should go underneath this 0. So 2 times 4 gives me 8. 2 times 3 gives me 6. And 2 times 7 gives me 14. So I bring down the 4, and then I carry the 1. Then 2 times 1 gives me 2, plus 1 gives me 3. If you want to do the 0, you can. But remember, 0 is a placeholder. We're okay with that. If you want to put it down, if you want to put the zeros in, you can do that. So there'll be a 0 here. 1, 2, 3, 4. Okay. So now all we have to do is add. So this 4 comes on down. 3 plus 4 gives me 7. Okay, are we rounding as well at the end? I wasn't planning on it, but let's see. I was just doing regular multiplying, but we could. 7 plus 8, that's 15. Carry the 1. So that means you have 1 plus 1 gives me 2. And then 4 plus 6 gives me 10. So that's 12. Carry the 1. 4 plus 1 gives me 5. 3 plus 1 gives me 4. And if you want to bring down the 0, you can. All right, so all the hard stuff is done. 12, yes. Because if I go 1 plus 1 gives me 2. 2 plus 4 gives me 6. And 6 plus 6 gives me 12. So I put the 2 and then I carry the 1. So as we made mention before, we had 2 decimal places up top, 3 decimal places for the second number. So that means we need 5 decimal places below. So if I do it, I always start all the way at the end and I move over 1, 2, 3, 4, 5. So as you can see, this 0, it's a placeholder. I don't really need it. Okay? So sometimes when you get to this part, when you have to multiply everything by 0, you don't have to. Okay? So that means my final answer, I think someone had it, Cole House had it, Holly has it, someone else had it, hold on. Could have sworn, okay, maybe I'm delusional. Okay, it makes so much sense, thank you, not a problem. So that means you have 4 and this lovely number, so 5, 2, 5, 7, 4. Okay. So So you have 52,574 hundred thousandths. Woo! Try that. Exhausting. Okay, I just stick this in my calculator. Exactly. But here's the thing. Are you ready? If you're taking the AccuPlacer, there's going to be certain problems that you can use a calculator for, but you could only use the calculator that's in the computer. You can't bring your regular calculator. They won't let you bring a calculator in. And they have tons of these problems on those AccuPlacer tests. So I just want to let you know, you cannot use a calculator unless it's something of graphing, and you can use the calculator that's on their system. So you're going to have to know how to do this lovely stuff on your own. Okay, just a heads up. Okay, I have a degree in math. Awesome. I will be taking that, luckily. Good. Okay. Because I just like to tell people, because there's people that'll take the AccuPlacer and they're like, they wouldn't let me use my calculator. And I'm like, I know, and I told you that. But everyone's just so like onto their calculators. That's why it gets all kinds of crazy. But I need to help my kid, and she's not allowed to use the calculator in 5th. Yes, some kids, some teachers are like, no, you should know this mental math. And they keep forgetting that 4 years ago, or when she was in 1st or 2nd grade, she missed how to do this as a mental math thing. Sometimes I'm like, why are we forgetting? Like it just didn't exist or something. It did. Thousands of people have died. So why are we sitting here acting like it? Mine are in the 4th and 7th, so I'm here for the same reason. Okay. Kids shouldn't use a calculator until they're 21. Until you're ready to vote. But it's true. Like once the calculators got into the classroom, basically a lot of people forgot and just stopped doing mental math, especially multiplication and division. So that's a thing. That is a thing. All right. So rounding, adding, multiplying decimals. How we're feeling. She was homeschooled in Florida. Homeschool curriculum didn't teach decimals. Okay, that's another thing. Oh, I love talking to you guys. That's another thing. When it comes to the homeschooling, and I know someone that does homeschooling, she's been doing it forever in Georgia. And when it comes to homeschooling, you guys get to pick and choose what you want to cover. And it seems like they put a lot of emphasis on English, a lot of emphasis on history, depending on where you're at, science, but a lot of them will not push math. So they can probably, you have a kid that will do all the content, but not so much with the math. And I'm not sure if it's because, parents don't know how to do the math, or the kids are just intimidated by the math, but they just kind of sketch over in the math department. So that's why I've been really trying to up my services with people that are doing homeschooling. If they just needed someone to help teach it, or I can teach the parents and they can teach their kids. Okay, but we all know that there's a different breed of homeschool parents. There were some people that just took their kids out of school and just expected the kids to do the curriculum completely on their own. And then they're shocked, like, all right, I left you alone for 2 months. And what do you mean you didn't do any of the work? What were you doing while, So it's a whole ordeal. Okay, good. On that, we used the state of Florida homeschooling curriculum. It was a terrible 2020. I know. That's awesome. I hope he keeps the love of it. Yes, this is awesome for you to help for 5th graders. Yeah, by the way, yes. All right. So, done with decimals. Now we're getting to the piece de resistance. Word problems. And then we're done. You're like, my God, how long have we been on here? We've been talking for over 2 years. No, I know. Okay. I'm going to walk you through it. It's going to be okay. breathe. All of a sudden, there's like no hearts. Everybody's losing their mind. I don't want to do it. It's okay. It's going to be okay. All right. So I am not going to overstimulate. All right. So we're going to break this down step by step. Now, there are words, terminology that coincide. So I think, see if we can do this. We got this. Yes, we do. Thank you. And guess what? You're not by yourselves. Guys, keep thinking. No Squid Games. We're not doing it. All right. I'm not sure if you can see this. I'm hoping you can. Now, I'm not sure if you can do this, if you can take a screenshot. So you're like the creme de la creme. So see if you can take a screenshot. Is it possible? Do I need to zoom? Talk to me here. Yes. Let's do this. Okay, I need to be able to help my kids. I've forgotten so much. I have my MBA. Hey, I know, I've forgotten fractions. But how you feel now? Okay, you're better than me. Okay, good. All right. Okay, zone of friendship. Yes, got that. So if you can, these are going to be the most popular words. Of course, it's directly out of my book, and I'm willing to share. I think I can get it all in there. Should I do it individually? Would that help you guys out? This is so helpful. Not a problem. Okay, so you got the exclusive. This is what happens when you stay later. Okay, so the terms that is used for addition. So you add, more than, exceeds. Now, more than and less than, a lot of people get mixed up with inequalities. Inequalities have the word is in front of more than and is in front of less than. That's how you can tell the difference. Okay. All right. Let me know if you got it. I'm not sure if you can screenshot it or not. You might have to leave and have to come back, but I'll be here. Like, where am I going? Nowhere. It's just my cat that's just meowing. I love his meows. It just gets excited, and then all of a sudden it's like, meow. Like, I'm going to kill you in your sleep. Meow. Screenshot done. Okay. Anyone else? Are we like thumbs up? Give me hearts. Do you have the screenshot? Okay, so you have your subtraction. No, right? Multiplying and dividing. Okay. All right. If I need to bring this back, I'm willing to bring it back. All right. So, because it's Sunday and it's her day off. Yeah. Okay. Now, when it comes to the word problems, we just need to remember certain words have certain phrases. So let me see if you can see that now. All right. So 3 less than m. We know that less than is subtraction. But is it going to be 3 minus m, or is it going to be m minus 3? Which one? Now I'm feeling like that right now. So is it 3 minus m, or is it m minus 3? Okay. M minus 3, M minus 3, M minus 3. And zone of friendship, he did M minus 3 as well. Okay, Shorty, you've got 3 minus M. Okay. Okay, Cool House joined right back up. All right. One more? Let's see if we can get one more person. Okay, so we got 3 less than m. All right, so let's clarify. So since there isn't an is in front of the less, it's not an inequality. This will be minus. Now it's saying 3 less than m. So that means the 3 is going to be lower than the m. Easier way for me to remember is when you see less than, you switch it. They switch positions. So it's actually going to be m minus 3. Okay, so 3 less than m. So anytime you see less than or greater than, you switch the spots. Okay, so it's not this one. All right. So y decreased by 10. What does decreased by mean? 10. What does decreased by mean? Sorry about that. Just my phone's about to die. My phone is just like, what? You are never on me this long. Okay, minus, less than. So decrease by, so that gives you your y minus 10. Okay, the only one that switches is less than. Decrease by will give you subtraction. And the one thing I definitely had to do when I was in the classroom, I had to spell out the words. I had to spell out the numbers because a lot of our kids just do not know how to spell out numbers. And then they were getting checks. There was this one company in my local area. They're not in existence anymore. And they would rip the kids off because, you have to go by the written part of the checks when you're cashing it, not the numeric, right? So they were cheating the kids by writing a lesser amount in the written part, but then they were giving them a certain number on the number part. Oh, did I go down to that place? Ooh, do not mess with my kids. Don't do it. Don't do it. I didn't curse them out. I'm still here, so obviously I didn't go to jail, but I really just reamed it out. Where did the y come from? It was in the original equation where it says y decreased by. Okay, I just used a variable. So y decreased by 10, so it was y minus 10. Okay, product means multiply, yes. So how would I write the product of 5 and x? We can't see. Oops. There we go. Get that out there. Okay. 5x. So Brandon. Hey, Brandon. I was like, when'd you sneak in here? Okay. Thank you. Not a problem. So the product of 5 and x, product means multiplication. So this would give you 5x. Now, this is what you're not writing down. Please, you do not write 5xx. No. Okay? X no longer means multiplication. Just get it out of our heads. Okay? All right? So 5x means 5 times x, the product of 5 and x. All right? So we cannot do double x's because this is telling me 5x squared. Okay? So x's no longer represents multiplication. Okay? This language is more complicated than Chinese. I know. Welcome to my life. And I chose this life to try to break it down to people. Because this is the thing. For so many years, you know that X was multiplication. And that's why I always keep saying for our elementary school teachers, stop using the X, because it screws these kids up when they go into algebra. Because algebra, you're using X as an unknown. So X could be any number. It could be a positive number. It could be a negative number. But when you use X, a lot of kids keep thinking that you have to put the X's down twice. I was so proud of my 5XX. That's fine. But see, here's my thing. I'm glad that you did that, because now we can correct it. Okay? Now we can correct it and it won't get so confusing later. Okay? So if I just wrote 5x now, that's all I have to do. Yep, I don't have to do 5xx. No, you do not. You just have to write 5x. Okay, you can write 5x like this. You can put parentheses around the 5 and parentheses around the x. You can write it like that. But majority of the time in books, you're going to see it as 5x. Okay. All right, so the next one, the quotient of n and 7. What does quotient mean? I hate verbal to algebra problems on SATs. They come out so much. Of course. Yes, so it is division. So how would I write this? The quotient of n and 7. So quotient means division. And remember what they say, division looks just like a fraction. There you go, clinical cover. Good. Nice, Nicole. I haven't done algebra in so long. I'm lost. It's okay. All we're doing is translating. So quotient means division. So the first number that you get, or in this case the n, will be your numerator. And the next number that follows, that's going to be your denominator. So all we're doing is translating from words to a fraction. All right. Okay. Now, this one comes up quite often. 60 miles per X gallons. That should be plural. Okay, so 60 miles per X gallon. Holly, so hard for me. My level was very, very bad. Plus, I studied math in Arabic. Okay, all the words is new for me. And that's fine. That's perfectly fine. You know, but you're here and you're trying. Okay, Holly, please don't beat yourself up, okay? Please don't. Okay? Because that's true. And that's another reason why I don't like assessments, because I'm tutoring a kid from Jerusalem, and he's here in the States, but you know, English is not his first language. And they made this kid take a test and they're like, oh yeah, you're really low in math or you're really low in English. Well, duh. English is his second language, you know? He didn't have to do all this stuff, and they didn't have Algebra 1, Geometry, Algebra 2. They just had like basic math. And that's what he was learning. Yes. So yes, 60, and this is the thing that gets a lot of people. Per gets a lot of people because we're used to seeing per as division. But when it comes to miles per hour, it's actually multiplication. So it's going to be 60x. Okay, so it's going to be 60x. So anytime you see an equation, and they always do like an equation line, It's not division, it's multiplication. Okay, it is going to be multiplication. I know in here per is division, but when it comes to per gallons or per miles or per whatever, it's always set up as multiplication. Again, it's almost like saying there, like THERE, and there with THEIR. We just like to make things so difficult. All right. Okay. How are you guys holding up? I know it's been a nice, I mean, you're doing math. A lot of you guys have been here since the beginning, and we started at 4:30. We're going for 2.5 hours. Woohoo! Well, go till the wheels fall off. All right. So now this one's a little tricky. Okay. 6 times the sum of x and 7. Whoa. Okay. If you could, make sure you drink water. Thank you. I needed that. Because I know I'm only going to be like downing it like I'm doing shots. But 6 times the sum of x and 7. How would you do that? Look at clinically clever. Silver Forest. I was washing dishes and listening to you crushing it. Yes. Look at the encouragement, Lucas. I love it. Yes, Nicole. Good. So 6 times the sum of x and 7. So if we think about it, there's 2 things happening here. One is the sum of x and 7. That's one thing. The other thing is 6 times this. Okay? Anytime you see sum of, that's going to be addition. But the 6 is being multiplied to the sum of. It's not just being multiplied to the x. It's not just being multiplied to the 7. It's being multiplied to both the x and 7. So that's how they're getting the 6 times, when we do parentheses, because remember, multiplication, you got parentheses. The sum of, that means we're adding the x and the 7. Okay, hey Nicole, we're proud of you for getting those dishes done. Yes. Glowing potato. How are you, dear? All right. How are we doing? I know we're starting to fade. I get it. I forgot those questions wrong in the SAT. But that's all right. Now we're tweaking, okay? Now we're tweaking, Brandon. We're doing well. So now, let's try this one. The product of 4 and x divided by 3. It was a lot of them, right? We're on word problems. Yes, we are. We're still here. Native probably went out, changed the oil in your car, did laundry, fed the nearby cat, came back. Yep, we're still doing math. I feel so much confident about this so I can help my kids. Oh, that's so good. So I got 4x over 3. I got 4x divided by 3. All right. Hello, Sarah. Oh, I had a flat tire today. Ugh, that's the worst. It's the worst. But guess what? We can get it fixed. We can get it fixed. It's cheaper than having your transmission blow, okay? let's look at the positive. Yeah, that was me this summer. Yeah, that was fun. 4x over 3, 4x over 3. Yes. So we got two things going on here. We have the product of 4 and x, so that's one thing. And then they're saying divided by 3. That's the other thing. So yes, product means multiplication, so you have 4x. And divide it by 3. So that means the whole thing is being divided by 3. Also, can you show a quick snippet of the notebook I want to purchase? Oh, okay, sure. Oh, wait, I'm sitting there looking at it. I'm like, where's my book? It's right here. Okay, so right here, the math notebook. Okay, it's called the Ultimate Math Notebook. I know, I felt a little facetious that day. So again, you can keep all your notes, have that organization. You got your formulas off to the side. So it's a quick reference. Plus it has like your steps. I think the next book that I'm going to do, I might do an improvement of this one and use more dot drills. I love the dot drills because it helps, especially with the graphing piece. It makes your graphs look so much cleaner than I would for over on the other side. So again, it's called the Math Notebook. There's 3 different covers of this, but this is the most popular one because I'm probably constantly promoting it. All right, so it's definitely on Amazon, and you can just go through Amazon. You can type in Audrey Codner, or you can, and this will pop up right away. All right. Okay. Thanks for being amazing. Oh, not a problem. I hope you have a wonderful day. And if you want to join us, do not forget you can join tomorrow. I'm just going to be finishing up this page, and then I'm going to try to finish my video so I can break that down and put that up on TikTok. Followed you so I can come back for more work. Yes. All right. Have a great night and awesome job. Awesome job. I used to have to graph those doors. Oh my gosh, I know. All right, so here we are. Let me see if I can get back into focus. Okay, the difference of a number and 6 divided by 12. The difference of a number and 6 divided by 12. All right, awesome. All right, so we got Brandon's. Ordered my book. Thank you. Oh, not a problem. Thank you. I greatly appreciate this. I know it's going to help. I'm not going to say I hope it helps. I know it's going to help, especially for the organization. And then on top of it, if you do your notes, because my notes I usually write big because of this. But after you do your notes and you know someone else is taking that same course, you can sell the book back to them. Hey, I don't know. I'm always thinking outside the box. So we have 6 minus x divided by 12. 6 minus x divided by 12. I'm heading out. Okay, I have to finish my driver's ed homework. Yes. Not a problem, Brandon. Anytime that you need help, I'll be here tomorrow night, okay? Have a good night. All right. So a number, a lot of you guys want to use x, which is good. So difference means subtraction. And this whole thing is being divided by 12. Good. I was like, I love the positivity on this group. I'm loving this. And you guys are really sticking with it. All right. It seems like you guys are getting this. Can I step it up a little bit? Just for us to kind of finish it out. So how about we do this? In your words, let's see if I can put it up. Translate this into verbally. How would you write that? Put it in the chat. Hi. How are you? Misbehaving. So for that and that, I don't want to say anything more because I'm probably giving it away. How would you write that verbally? And you can put it in the chat. You can. That's hard. I know. Try your best. Try your best. You don't have to get too technical. I'm stuck. That's okay. So write out the numbers. Okay. The difference of 4 minus 6 times. I don't know, honestly. Hey, you were close. You were so close. This is a 7 instead of a 6. Okay. And you are saying difference. You don't have to say difference and minus at the same time. Okay, the product of 7x taken from 4. Yes, Nicole. There's so many different ways, so it's not exactly what Nicole just said. So that's why I was able to correct really, really fast. Native Ash, you're right on top of it. Hey, Pops! Okay. So 7x plus 4. Now, misbehaving, I know you came a little later. But we're actually going to write it out almost like if you're writing a check. So write the numbers in as words. Okay. So 4 minus the product of 7 and x. Good. Native Ash. You're right there. You are right there. Give it a try again. Hey, Willie. Give it another try. You got it. Because you were like right there. Difference of 4 minus 7x. Instead of the minus, put and. Okay, not bad. Because the difference is your subtraction. So look what you wrote previously. Rewrite that. But get rid of the minus and put and. Okay, do this. The difference of 4 and the product of 7 and yes, Leanne. The product of 4 lesser than 7. Ooh, look at you, Holly. 4 lesser. Let's see. The product of 4 lesser than 7. How about the product of 7 and x lesser than 4? That will work. That will tweak it. So the difference of 4 and 7x, we can say that. And that 7x could be the product of 7 and x. It could be 7 times x. It could be 7 multiplied by x. So you see how you can break up that 7x piece? Okay. All right. So we got this. Yes. Okay. So this is tough. Trust me, because especially with the English portion of it, okay, it is a little tough. And you notice that you don't get the same exact answer. So you can say the product of 7x less than 4. You could say 4 minus 7 times x. You could say the difference of 4 and the product of 7 and x. So you see how you can have multiple, exactly. Hopefully this will be a multiple choice question. Yes, usually it is. Okay, usually it is. Especially when you take a look at the operation in the middle. And then you can just see, I always like to do process elimination, especially GED or Accuplacer or ASVAT. They always have this, and you can do process elimination. So if they say plus, obviously you're going to cancel that out. All right, not too shabby, guys. Ooh, good question. So if we have 4 minus 7x, the minus sign is attached to the 7. So if you are going to flip it, that means your 7x has to be negative and your 4 has to be positive. Okay, so they're not the same if you say positive 7x and minus 4. Because remember, your positive and negative is always in front of the 4. And your signage, I should say, is always in front. So like this minus sign can act as a negative when I flip it around. Okay, does that make sense, Sue? Okay, so good question. All right, couple more and then we're done. I swear. I swear. Okay, so can we tap it? Can we get to like 14K? I mean, not 14, 18K, because we're past 14. Is it possible for us to get to that? Can we tap the screen for a bit? Oh, awesome. How often do you go live? I'm new here. I just started going live seriously last week. So I'll be here at 1 p.m. Eastern Standard Time, Monday through Fridays. And Monday through Thursdays, I'm here from 8:30 p.m. Eastern Standard Time to Thursdays Eastern Standard Time. Okay. Oh, I'm glad. I'm glad that you're here, Holly. I'm so glad that you're here. I'm glad that this is being helpful. Okay. I don't want it to be stressful, but I want you to feel like you guys you're rocking it. Like you are totally rocking it out. All right. This may seem a little distant, so I'm going to try to do a little bit of word problems. I have a total of 5 word problems, and then we're done. Okay, then we're done. Okay. Plus, I have to feed cats. Seems like they're just like, she doesn't love us. Meanwhile, before I came on here, you would think that they've never ate, and I've given them so much food as is. Okay, I appreciate it. I'll be taking my GED soon. Cool. Okay, good luck with that. And yes, and here's the thing, because tomorrow I'm going to start more on the linear stuff, like more of the graphing and slope. In the GED, you have, everything has a certain point value. So you have 1-point questions, 2-point questions, 3-point questions, and 4-point questions. Anything dealing with linear equations, those are your 4-point questions. So if you can come back tomorrow or anytime at like 1 o'clock when I'm on, that will be awesome, because those are going to be talking about those 4-point questions. Because if you can get that, you can pass the GED, like hands down. All right. And remember, we don't need 100%. We just want to pass this bad boy so you can move on with your life, right? I didn't know that. Yes, thank you. Yes. So like all the stuff that we did with the decimals and the percents, they're mostly like 1 point questions. But if they put it in like a word problem, that's more like 2 point questions, possibly 3. But anything dealing with the algebra, with the graphs, domain and range, that's those 4 point questions. And you definitely need to get those. All right. It's hard to learn online when you can't ask questions. This is very helpful. Oh, not a problem. I got to do the PERT test to get into the to college classes. Yes. So the PERT I think is close to the AccuPlacer. Yes. All right. So zone of friendship. I know you're trying to keep me in track. Thank you. I struggle with that, but I met a teacher who changed my life, and I still remember him. Awesome. All right, so here we go with the 5. A cashier contains D dimes. Write an algebraic expression that represents the total amount of money in dollars. Okay, so first off, this is another thing with English. You need to know how much a dime is worth. Okay? If you are new to this country and you don't even know what a dime is, it's going to be hard for you to answer this question. But a dime is worth 10 cents. How do I write 10 cents as a decimal? Okay. I know. Thank you. You guys were tapping like a crazy fiend. Thank you for the 20. I appreciate it. Yes. So you have your 0.10 or 0.10. So that's the cost of a dime. But we don't know how many dimes we're dealing with. So that's why we're multiplying it to our D. Okay? So anytime you see word problems, system of equations always use something similar to this, okay? So first we need to know how much a dime is worth. It's 10 out of 100 pennies. So that gives us our 0.10. And then how many dimes? We don't know. But all we're doing is looking at the algebraic expression. So that's where that 0.10 D comes from. Okay, that's all we have to do. Me being from England. Yes. All right. Whereabouts, Lucas? Whereabouts in England? I used to play for Ipswich many, many moons ago. I was an Ipswich Wildcat. And then let me move this over. This is going to be a little hard to read because... Oh, wait. Okay, I was able to shrink it a little bit. All right. So now this one is saying a campground charges $15 for adults and $2 for children. Write an algebraic expression that represents the total camping fee for M adults and N children. So they're telling you that M is supposed to represent the adults and N is supposed to represent children. So they're giving you the key. So how would I write that algebraic expression that we're dealing with in that first sentence? Grades do I teach? 7th, so basically algebra 1 all the way up to adults. So I have algebra 1, algebra 2, trigonometry, geometry, pre-calculus. Now I'm starting to do AP pre-calc. That's always fun. But I like to stop right there. But then I also help with like people that are doing intermediate algebra at the community college. Been doing a couple of those this year. Been doing a lot of those this year, to be honest with you. All right. Oh, Midlands, Camden Town. Okay. All right. So yes. So if it's $15 for adult, so that means it is 15M. And $2 for children, so that'll be 2N. Okay, and they want us to know the total. So if we're doing a total, that means we're adding those two together. All right. You're a teacher or a tutor? I used to be a teacher. I taught for 22 years throughout Maryland, and now I own my own tutoring company. This is my 5th year of doing this. I love it. I actually do love it. It gives me like different things. Yep. All right. Almost done. 15 is a little steep compared to 2, right? We didn't say that the math problems made sense. Like that one time I was calculating and they're like, oh, $5 for an eraser. I'm like, who is paying? Only math can do that. Like, how many watermelons does a kid need to buy? Like, why does Jim Rawl need to buy 15 watermelons? Where are you going? What's happening? $5 for an eraser. Like, I know inflation's up, but my goodness, it's crazy. All right. So the hourly wage of an employee is $12.50 per hour, plus 75 cents for each of the Q units produced during the hour. So say that this employer is making something. So how many units they're making that they can produce during an hour. So write an algebraic expression that represents the total hourly earnings for the employee. So how would I represent? All right, Sue, yes. Odom, yes. Look at this. Look at all this greatness. I'm loving this. Access granted. Rethink. You guys are so creative with your names. Just so creative. Kills me. Okay. So we started off with $12.50. And they get an additional 75 cents for every Q unit. And I don't know how many there are, but that's why we use the variable. Okay. All right. So we don't know how many units. So Holly, you're using minutes, but we don't know about the minutes. Okay. So the Q is going to represent the number of units, how many hours. So what about the hour? Right. All of this is happening during the hour. Okay, all this is happening during the hour. So they get paid this an hour plus the 75 cents, but this is happening during the hour. Okay. So then if I went and I plugged in, I know I would do $12.50 plus the 75. So that'll give me what, $13.25 in 1 hour? We're okay. All right. All right. Okay, cool. All right, so 2 more. So this one, I think I wanted to advance up a little bit. So this one, I want to do I think it was this one. So 15 is subtracted from x, and the difference is multiplied by 4. So 15 is subtracted from x, and the difference is multiplied by 4. Ooh, Leanne, you're really close. What's missing? Okay. What's missing? Okay. Holly, you're really close too. What's missing? Okay. Yep, zone friendship, you can do that as well. Because I was just about to work on that too. Okay, Nicole. Okay, native, you're close as well. And then Caitlin, there's something missing with yours as well. You're very close. Okay. So you have your 15 is subtracted from x. So that means your 15 is the one that's carrying the minus sign. And the difference, so this, x minus 15, is multiplied by 4. A lot of you guys are just putting the 4, but you're putting the 4 in front of the x. But it's multiplying not just the x, but also the 15. Okay. The order of subtraction matters. It does in this case, because since they're saying 15 is subtracted from, so that means the 15 is being taken away from whatever x. Don't worry about it. Caitlin, it's fine. I'm bad at word problems. Why do you think I'm doing this? Not just because you're bad at word problems, because you're not the only one. A lot of us are, okay? All right? A lot of us are. So when you do this part, the 15 is subtracted from the x, then this answer is respecting the difference. And it is multiplied by 4. So you're multiplying the 4 to the entire difference. So we did distributive property. So you can leave your answer like this, or you can do what's called the distributive property. If I do the distributive property, that means I'm multiplying everything by 4. It said, that's okay. Would that be wrong if I put 4 in the end? You can say x minus 15, but as long as you put parentheses and then the 4, that's fine. Okay, that can work. All right. So we're taking it step by step, guys. Again, not Squid Games. Not doing it. Okay. So 4 times x gives me 4x. Then 4 times negative 15 gives me a negative 60. So you can have your answer as such, or you can do the distributive property as such, or you can have your 4 at the end. That'll work. I know, right? I don't want to insult, but I'm just like, everyone's just think they're just going to get popped off. Like, like that's it. Oh, wrong answer. Done. Like, no. Gina! How are you? Okay. So then I'm going to, okay. For the last one, I have two examples here. I have one that says, ooh, let me straighten that out. I have one that says twice a number increased by 5 is 21. So we're actually doing some solving. And the other one says the sum of a number and 1 divided by 3 is 8. Slide over so you can see that is 8. Which one would you like to do first? Okay, which grade they study this math? Again, it's not so much, I mean, I know it's mostly like some elementary will start it off, but yet middle school also does it as well. So it also depends on the kid. Okay, so some people say the 2nd grade, some people say the 8th grade, some people, especially for word problems, I can see mostly an advanced 6th to 7th grader and some 8th graders. Okay, all right, so the first one, the second one. All right, so I got 2 votes for the second one, got 1 vote for the third one. So I'm in the 8th grade and we learned like last month how. Okay. All right. The second one, the first one. All right. Well, it's even Steven, so I guess it doesn't matter. All right, so here we go. We're going to go with the first one, then we're going to go with the second one. Let's translate it, and I think it'll be better so I can zoom a little bit so we can stop going blind. All right. Twice a number increased by 5 is 21. How would I write that as we like to call it, an algebraic equation? Okay, twice a number increased by 5 is 21. So how would I write it as an equation? It's a Tuesday. What is everyone's obsession? Or Wednesday? Okay. It's almost like all my students want to be off tomorrow. It's all right. More time with you guys. Because I guess everyone's off tomorrow. So what do you think, guys? What's the equation? We're going to solve it, but let's set up the equation. Twice. What does twice mean? Two times. Yes. Okay. So 2 times a number. So let's say that the number is x. All right. So how would I write 2 times a number? How do I write? And times is multiplication. Good. Good, Caitlin. Nice. So we have 2x. So we got that part. Good, Gina. All right, we're okay? All right. So now, increased by 5. How would I write increased by 5? Okay, didn't mean to put the 7. Okay, I figured that. Because I was like, how is she getting the 7? So increased by 5 plus 5, good. Is, what does the word is represent? What does the word is represent? Is 21. Okay, Caitlin thinks it's equals 2. I love it. So equals 21. All right, good. All right, so you just created an equation. You went from verbal to algebraic. You should be cheering yourselves on. Cheer yourselves on. All right. So now, I want to know what this mystery number is. How can I get this mystery number? So I have 2x plus 5 equals 21. When I'm solving the equation, I want to isolate my variable. Remember, the equal sign is like a barrier. All right? Equal sign is like a barrier. So right now, 2x. Your x, 2 is your boo. So you're up in the club. Here comes, it's just you and your boo having a good time. Here comes plus 5 just trying to wreck it, right? Yes, ORG, we need to get rid of. We need to move this 5 to the other side. So we do the inverse, which is plus. So the inverse is going to be minus. So we need to subtract that 5 out of our lives. It's almost like relationships, right? So the 2x comes down because positive 5 minus 5 gives me a 0. Now, we don't need the 0 because the 0 is a placeholder. So we're just going to bring that 2 down as well as my equal sign. So 21 minus 5 gives me what? So we got 16. There you go. So we have 2x is equal to 16. Look at this. I love it. I love it. All right. So all of a sudden, your boo's acting up. No recovery. Got to dismiss them. So 2x means 2 times x. What's the inverse? Yes, Gina knows it. Yes, Caitlin knows it. We got to divide that person out of our lives. So we're dividing both sides by the 2. So 2x divided by 2 will simply give me x, or 1x. And we all know that 1x and x means exactly the same. I read the problem. Okay. So then 16 divided by 2 gives me 8. I would love to know, why not divide first? Okay, we need to isolate our variables. We need to isolate that variable before we do anything. Because if I divide everything by 2, I'm going to have a 5 halves, which people don't like fractions. We already went through that earlier. 21 halves. No one likes that fraction. Okay. Divide by 2, then subtract 5 halves. That's true. You can do that. But a lot of people don't like fractions. But even though we just went through it, you can do that as well. Okay. Yep. So you do get your answer of 8. Okay. Okay. But you can do the 5 halves. You can divide everything by 2, but a lot of people like to isolate first. So this is saying that 8 is going to be the number when multiplied by 2 and added to 5 is going to give us a true statement of that 21. Okay. All right. And the last one for the night. Man, you guys are troopers. I love it. Okay. So, what kind of question is that called? So I can practice it. It's just basically solving, like translating algebraic expressions or equations. So translating, let me write it down so you can see. And if you want more practice with the solving, this is considered a two-step equation. Okay? The reason why we subtracted the 5, then we divided by 2. So this is really called a two-step. We'll get a two-step equation. Okay, thank you. Not a problem. All right. Okay, sliding over. So the sum of a number and 1 divided by 3 is 8. Hey, Kim. You're back. Yeah, we're still here. So the sum of a number and 1 divided by 3 is 8. This feels like a fraction. Ooh, you are so right, Lucas. Tokyo Drift, how are you? Okay. Set it up first. Set it up and put it in the chat. Let me see, so we can make sure we're all in the same position. So sum of a number and 1 divided by 3 is 8. X plus 1 is the numerator. Yes. What's the denominator? Yes, Holly. Just finish it out, Holly. Is 8. What does is 8 mean? Aaron! I feel like Cheers. Like, Norm! Hello, ZB. You're like right there. So we got a couple of things. We have the sum of a number and 1. That's one thing. Then it's being divided by 3. That's another thing. And then it is 8. Hello, Grace. What will be my equation? Okay, you guys okay? I see a couple hearts here and there. I feel like I'm in grammar school all over again. Oh, why? Is it because we're waiting? Oh no, I don't want that feeling. No, don't do that. He was like, who's gonna be brave to put it back up there? Let's see. I think our comments are being filtered. Oh, why? Maybe because I'm on here too long? I don't know. All right. Well, spies like us. This is what happens when it's all kinds of fun. Okay. Yes, I think so too. Aw. All right. Well, let's finish this up. So, the sum of a number and 1, how would I write that? Because I don't think you see what I put in. No, I didn't. I didn't see anybody else's. No, I didn't see anybody else's either. Okay, so I saw the x plus 1s. Okay. Okay. Now it's going to be divided by 3, so that whole thing's being divided by 3 is 8. What does is 8 mean? Yep, got the divide by 3. Good, Nicole. Equals, good. So equals 8. Okay. What does that mean? All right. Oh, okay. That's supposed to be equals. All right. I got you. All right. So now we have a fraction here. Times 3 on both sides. Yes. Okay. Anytime you have a fraction, that means division. The opposite of division is multiplication. So you multiply both sides by whatever your denominator is, which in this case is 3. Thank you, Inspector. Okay, as a mathematician, I might disagree with your breakdown. Commas are important. There's no commas. So anyway, so we have 3 divided by 3. That gives me 1. So what's left when we do 3 divided by 3? What's left is x plus 1 equals what? I got you. I love you, Gina. Trust me, I'm good. I was like, this indication, multiplication. Okay. All right, we got our 24s. Good. So now we want to get x by itself. What do we have to do on both sides? So we need to get x. Yes, 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 yes. Okay, so we have plus 1, so we always want to do the inverse. So we're going to subtract 1 on both sides. So this is going to tell me that x is equal to what? Yes, good. Good job, guys. Look at you. I'm so proud. We did it! Ladies and gentlemen, you guys did math for, 3 hours and almost 15 minutes? And you didn't want to kill anybody. Isn't that awesome? You didn't want to throw anything? Oh my goodness. Lucas, don't worry about it, my dear. Don't worry about it. Oh, don't even worry about it. Oh my goodness. So, yes. So anything, don't worry. Don't worry. I was waiting. I was just like, dude, I'm surprised this is my second week and I haven't gotten a troll yet. I'm like, dude, I feel like left out. But I got one. Yay. Okay. Not a problem. Oh my gosh, you guys did amazing. Absolutely amazing. I love it. I love it. It's starting to be clear and simple. Yes, good. Yeah, I already muted him, so now he gets to watch us. Isn't that creepy? Okay. You got one now. Yay! Haters are a great sign, right? See, Summer, we get it. I was like, I never enjoyed math this much. I was like, I am so very proud of you guys. And I mean, like, these, like, if we can get this down, the foundations of this, like fractions, decimals, word problems, even simplifying fractions, trust and believe you can do almost any type of math. And just like what's his name said that, you know, yeah, no stand up for. Yeah, that was fun. But at the same time, it's like once we get this foundation piece, like you can do almost any type of math. You can basically manipulate numbers as well as you want, especially for statistics. And that's why me and statistics are not best friends. Like, you know, we're there, we say hi, we may see each other in the party, but that's about it. Like, it's not going any further than that. But when it comes to statistics, like you can manipulate numbers for them to support your cause. Like I was listening to the radio and there was some online preacher that was talking about the effects, the negative effects of living with someone before being married. And he said like 45% of couples, you know, they get divorced if they were living together before they got married. And I'm sitting here, I'm like, wait, so that means 55% of it is good then. And it was just like hilarious for me. Oh my goodness. But anyway, it was really fun to hang out with you guys. Thank you so much. I mean, thank you for the likes. My goodness, 26, almost like 27. Oh my gosh, that's crazy. But at the same time, you guys did fabulous. You're doing amazing work. I love the fact that you're here. I love the fact that I was able to kind of ease a little bit of the stress of learning math. Again, if you want to come, I'll be here at 1 o'clock Eastern Standard Time, as well as 8:30 Monday through Thursday Eastern Standard Times. And thank you for those that bought the book. If that helps out, that's great. And if any of you guys are taking college classes and you need I need some assistance and you want to do almost like a study group, please let me know. I am slowly but surely trying to figure out, I think I put it in the chat or one of my lives or something, that if you want to do a study group, just there's like a, what's it called? Google form that's out there. And we can actually and I want to do a couple of them this week. If you need it, just message me and we'll just make arrangements so we can just do a study group. And I'm basically not using it for mostly money. I'm just using it for like donations. So if you want to donate, you can donate. That's perfectly fine. Whatever you feel fit or whatever you can afford, that's it. You know, because I do still have my tutoring clients that I can rely on. But if you would like to get into a study group and to help you with your current math class, just let me know. All right. That's just a TikTok special. Since you guys are done with you. Oh, thanks. New followers. I love that. There are lies, damn lies, and then there are statistics. I love that. I'm working on studying for the T's and my to study. Yes. Me rising. Yes. Okay. So if anything, oh, hey, Kelly. If you do need, just please DM me because that'll be so much easier. I'm going to see if I can be friends with everybody and then find the DMs. And then I will get back to you. Or you can go to my website, which that link is in my bio. And if you just send me a quick message, then I can talk with you and then I can probably put the groups together. I think that would be like the best thing for me to do. All right. Well, everyone have an amazing evening. I mean, this was fun. This is better than me sitting around like, oh, my student's canceled. I'm so sad. So thank you. You made it fun. All right, now I'm going to go and please put me, okay. Yes, please, if anything, go to I think that'll be the best thing to do. Go to, because my brain will be completely scrambled. Go to my profile, click on my picture. You'll see acgmathtutoring.com. Click on that and then just fill out the information form. And I'll be looking out for you, Holly. Okay? All right. But if anything, I will see you guys tomorrow night. Lucas, look at you. You're at the #1 spot. Good job. You made it, buddy. All right. Have a lovely evening. Oh, you're a godsend. Thank you, Gina. All right, have a great evening, guys. Please take care of yourself and please be safe. All right, everyone's losing their damn minds. It's ridiculous. All right, just be safe. All right, have a good night.